So chemical bonding, before we talk about chemical bonding, let's look back at the periodic table. And we wanted to look at the groups. And so when we look at groups, we want to talk about electrons. And so when we fill electrons, we start off with hydrogen. It has one proton. It's going to have one electron. So it puts that one electron in the lowest energy orbital, the most inner orbital. Next we go to helium. That's got two protons. So on the periodic table, so it's going to have two electrons. So it puts those in that same shell, which can accommodate two electrons, and now that shell is full. When shells fill up, that's where we want to be. They'll have the lowest energy when shells are full, when orbitals or shells are full. We go to the next row and we have lithium. That's in group number 1. It now has one electron in the next shell. So its valence shell, the outermost shell with electrons, only has one electron. So the idea is the periodic table set up this way so that the valence electrons line up. So all the atoms on the periodic table that have one valence electron, one outermost electron, are in row number 1. If we go all the way over to, let's say, group 7, column 7, we have chlorine, fluorine, all those, the halogens, they all have 7 valence electrons. So the idea is that's going to help us take a look at bonding and what certain atoms are going to do to bond. So the idea is we want to have full shells. So if we go all the way to the right, those are atoms that have full valence shells. So the idea is we're going to fill in orbitals, we're going to keep adding electrons until we get to a full shell, which are the noble gases. So they have full shells. They don't need to undergo any bonding. They're the most stable they can be. Why do you want to get any more stable? The whole idea is energy drives these bonds. Other elements can gain or lose electrons by ionic bonding, so they'll transfer electrons, or they can share electrons in a covalent bond. But either way, they're both trying to get to this octet rule. So the octet rule says basically atoms of elements try to attain a full valence shell, count of 8 electrons, to be like the noble gases. So the valence electrons are the only ones that are going to actually partake in bonding. So only the outermost electrons will actually partake in this bonding. So if it's going to be an ionic bond, it's going to actually gain or lose electrons. If it only has one in its outermost shell, it's very difficult to get 7 more electrons. So it's most ideally going to just lose that single electron, now have the full shell from the inner shell, and give that electron to somebody who may want it. So if someone is very close to the octet rule, let's say they have 6 or 7 electrons, they're going to most likely accept, through ionic bonding, a transfer of electrons and become an ion. The positive ones are cations, the negative ones are anions. So if you lose an electron, you become positive, a cation. If you accept electrons, you become a negative anion. So the way this works is, what ionic bonding is, an electron is transferred from one atom to another. This transfer, usually a metal, is given an electron to a nonmetal. The metal will then take a positive charge, becoming a cation. The nonmetal will become an anion, taking the negative charge. Depending on how many electrons get transferred, they'll take a +1 or a -1, a +2, -2 charge. But then what you'll do is you'll have these two things that are positive and negative, and as we know, opposites attract. So they'll have this electrostatic attraction that will hold them together. So if we look at sodium chloride table salt, you have a sodium, 1 valence electron, chlorine, 7 valence electrons. The sodium would lose the 1 electron, give it to the chlorine. Now the sodium is positive, the chlorine is negative, and they would stick together. That's how we form ionic bonds. Covalent bonding is, instead of actually giving the electrons, they actually share. So how do atoms share electrons? They actually overlap their orbitals. So think of these sort of spherical shells overlapping each other, crossing over. And when they share a single pair of electrons, they each contribute 1 generally. We call that a single bond. If they each donate two electrons, so a total of 4 electrons in the bond, it's a double bond. Triple bond would be 6 electrons. That's pretty much the maximum bond we're going to talk about in this class. Even in chemistry, there are cases where atoms will form more than 3 bonds, but it's very, very rare. And generally, covalent bonding takes place between nonmetals. So that would be, let's say, an oxygen and 2 hydrogens making water. That would be a covalent bond. Or if we had carbon and 2 oxygens, let's say carbon dioxide, again, 2 nonmetals forming a bond, that'd be covalent bonding. Um, what we want to do is when we start looking at bonding, we want to look at Lewis dot structures. So definitely pay attention in class when we talk about Lewis dot structures, or watch a tutorial on Lewis dot structures. Finally, like I say, when we're talking about covalent bonding, we're talking about polar versus nonpolar bonds. So if me and you were to share something, maybe I eat 3/4 of it. So we're going to share, a cookie, but I take 3/4 of the cookie and I leave you a quarter. That's not an equal sharing of that cookie. Well, bonding is kind of the same way, but it more has to do with the strength of the pull. So a polar bond is when there's an unequal sharing of electrons. So if we had two oxygen atoms sharing electrons, they actually are the same strength, right? It's based on electronegativity. There's a charge that tell us that oxygen has a certain electronegativity. Well, if there's two oxygens pulling, they're going to actually equally share because they can't pull harder than the other one. That's a nonpolar bond. But if we looked at something like carbon and oxygen forming a bond, or oxygen and hydrogen forming a bond like water, well, the oxygen can pull a lot harder than the hydrogens can in that water bond. So they're going to pull a lot of the electron density toward itself. So the oxygen would actually be polar. Um, a polar molecule, water, would have the negative end pointing toward the oxygen, and two hydrogens have slightly positive ends. So electronegativity, polar and nonpolar bondings can be a little complicated. Again, pay attention in class and you should be fine.